Man structures his world with steel. He uses steel to create the superstructure of the civilized world. It's the perfect building material. It's flexible, versatile, and incredibly strong. But corrosion is a fact of nature. Steel that is exposed to any combination of air and water is subject to corrosion. Moisture and oxygen combine with other elements to oxidize the metal and make it decompose. Until now, attempts to solve the problem have been short-term, costly, and ineffective. Paint that breaks down when exposed to salts and pollution, coatings that crack and allow corrosion to begin. Even worse, until now, steel coatings have produced dangerous byproducts called VOCs, volatile organic compounds that escape into the Earth's atmosphere and have a devastating effect on the ozone layer. So nobody has had a real answer to the problem of corrosion until now. Inorganic coatings has the perfect solution. A permanent coating that is as hard as steel, that chemically bonds to the surface of the steel, is easy to apply, needs no curing, and produces zero VOCs. The answer is a NASA-developed high-ratio zinc silicate coating called ic531. The Statue of Liberty, the greatest symbol of American freedom, a welcoming handshake to visitors to our shores. It's our proudest national structure, and it's protected by ic531. ic531 was specified for the restoration of the statue because it's the most advanced protective coating available in the world today. Over 500 gallons were used to preserve the interior wrought iron structure, not just for years, but for decades to come. The protective shield formed by ic531 is exceptionally hard and as permanent as the metal itself. To understand how it works, we need to examine the process on a molecular level. Steel is the perfect site for corrosion. The unique alloy composition of steel, which gives it its strength and flexibility, also makes it uniquely vulnerable to oxidation. The iron in steel reacts with oxygen in the presence of water to break down and corrode the surface of the metal. Whenever oxygen and water are present, steel rusts. There are three ways to prevent corrosion. The first is to apply a barrier coating, which mechanically bonds to the surface of the steel and blocks oxygen and water. But when this organic coating is damaged or breaks down from exposure, rust occurs. The second method is galvanizing, which operates on a completely different principle. Pure zinc, a less stable metal than the steel alloy, is applied directly to the surface. The zinc oxidizes or sacrifices in place of the iron and steel, leaving the surface of the metal intact. However, exposure to extreme conditions such as marine environments, road salts, or acid rain causes the zinc to sacrifice rapidly, and protection may be lost in as little as 3 to 5 years. The most effective solution ever developed for steel protection is high-ratio water-based zinc silicate, which is a sophisticated combination of the galvanic and barrier concepts. It's made up of 90% pure zinc and 10% liquid glass, and it forms an impervious chemical bond with steel. SiO2, the active component in liquid glass, reacts with the steel while it encapsulates every zinc particle to form a hard, slightly porous film. At this point, a two-stage process occurs. The 90% zinc component oxidizes or sacrifices to save the steel. The zinc oxide products formed by this reaction fill the pores in the coating, packing it tighter and tighter to create an impenetrable zinc ceramic barrier that will not break down over time. The high-ratio ic531 formula provides permanent protection, and the proof lies in the long history and evolution of zinc silicate coating chemistry. The idea for zinc silicate coatings has been around since the 1930s. In 1942, Victor Nightingale guaranteed the first zinc silicate coating on the 250-mile Morgan-Whyalla pipeline in Australia. Since 1942, after decades of exposure to coastal salt spray, direct sunlight, and brush fires, the coating remains in excellent condition. There is no loss in millage and no breakdown, even on joint welds. Since 1942, research continued on zinc silicate chemistries, but they all required a post-cure with heat or acids, or long periods of self-curing. Then in the early 1970s, NASA achieved a breakthrough in inorganic chemistry. By raising the ratio in the silicate formula from 3.2 to 1 to 5.3 to 1, NASA had turned theory into practical reality by perfecting the first no-cure zinc silicate coating for steel, ic531. Now a new standard has been set. The advantages of high-ratio ic531 set it apart from all other coatings. ic531 is easy to mix and apply. It dries fast. But most importantly, its high-ratio chemistry needs no curing. When it's dry, it's cured. And that means high production throughput. Now you can tote or ship in 2 hours. ic531's no-cure advantage assures you of the highest quality application, with no surprises down the line due to incomplete curing. And ic531 not only dries fast, it dries hard. It bonds chemically to the steel surface with immediate high adhesion and hardness. It's so tough that you can take a hammer to it in as little as 30 minutes. A single coat of ic531 will last for decades, and because it bonds to itself, it can be retouched indefinitely. That means you can preserve your steel indefinitely. ic531 is 100% water-based and produces 0 VOCs. It cleans up with water, so there's 0 solvent chemical waste. By using ic531, you can save your steel investment and take a real step toward saving the environment right now. All the advantages of ic531 deliver lower cost, higher profits, and long-term protection that will continue to save real dollars in the future. When you build with steel, you are creating the future. Protect your investment with the ultimate achievement in corrosion prevention for steel, ic531.